In this last section, when talking about composition of functions and operations on functions like addition and subtraction, your book also mentions what's called the difference quotient, which we just start learning about now. It actually becomes a lot more important later on when we get to calculus, but we might as well look at it right now as a precursor to what's coming. And essentially the idea is, suppose we have something like f of x equals x squared. Then I want to find f of x plus h minus f of x all over h. Just use my rules for functions and I can plug in. And we'll explain what's going on later. For right now, well, let's see. F of x is x squared. So f of x plus h, we plug in x plus h, and then we square it. Minus f of x, which is x squared, all over h. That's it right there. But here we can do algebra and simplify all this out. So let's see. FOIL that, and you'll get x squared plus 2xh plus h squared minus x squared all over h. Now, x squared minus x squared cancel, and we're left with 2xh plus h squared all over h. Here there's a common h on top, so factor it out. And we get h times 2x plus h all over h. Now those h's cancel, and we're left with 2x plus h right there. For the purposes of this class, we can actually stop right there. We simplify that out as much as we could. Ultimately, the idea is when we get to calculus, we'll do this a trick, and essentially we'll make all our h's 0, so that will disappear. And our answer will be 2x. You don't have to worry about that for right now. That's something to come later on. So for right now, 2x plus h is our answer. As far as what's going on, essentially, well, since we had x squared, suppose we look at the graph right there. X squared, we know, looks like this. And suppose I want to find the slope at some point. Say this point right here. Call it x. And then obviously over here, this y value is f of x. Well, the problem is lines have slopes that are constant. Clearly, this quadratic has a lot of different slopes. Sometimes they're negative over here because it's going down. It's positive over here, and they're not constant. And down here, it's actually 0 where it's horizontal. So the question becomes, well, how do you actually find the slope, say, somewhere on here when the slope is constantly changing? And again, this is more of a calculus idea, but it's a trick we can use. And essentially, we say, well, I'm going to pick some other point right over here to estimate it. And if that's x, I'm going to pick some distance h. So this point will be the point x plus h. Whatever this x value is, plus whatever h I make up right here. Then obviously, up here, we'll get the point f of x plus h. Well, now, if I want to find the slope at this point, I can just kind of draw a line, and I can use the slope of that line as approximation of the slope right here. But then by definition, what's the slope? It's change in y over change in x, which means the change in our x values, which is f of x plus h, minus f of x, all over the change in our x values, which is x plus h minus x. And then in the denominator, x minus x cancels, and you're left with f of x plus h minus f of x all over h, which is our difference quotient, which is actually where this comes from. Again, for right now, all we really need to be able to do is, given any function, plug in f of x plus h minus f of x over h, and then algebraically simplify it as much as possible, and we're done. But it leads to an idea that we'll see later on in calculus that's really, really important. So I just wanted to cover this really briefly right now.